Assalamualaikum and a very good morning. My name is Lukman Ul Hakim bin Tajul Arifin. So today I'm going to present about control system design lab 6, which is Ziegler-Nicholas method. So the Ziegler-Nicholas method uh, is a method that is used to tune the PID controller. So it is developed by the John G. Ziegler and Nathaniel B. Nicholas. So the method is used to control the PID, which the gain depend on the type of controller used and behavior described. So if we want to control the P, we will control the P, and if we want the P and I, we will control the PI, and if we want the PID, each of this type give different output, which increase or decrease the amount of error. So the Ziegler-Nicholas tuning method is used to uh, uh, used to tune the error, so it can be used for specific purpose. So the exercise is refer this closed loop system. So we refer this closed loop 6s plus 1, s plus 2, s plus 3 plus controller with one closed loop system. So from this closed loop system, we can do calculation, which is, as you can see, we combine the k with the gs, which is 6 s plus 1 plus 2 plus 3, and then after we combine, we give the closed loop into one open loop. So the final answer is this: 6k s plus 3 6s over 2 square root 6s plus 1 11s plus 6 plus 6k. So next, this is the answer for the step response from graph or for the closed loop system. So we use the coding this code to projectile this graph for the closed loop system. Okay, this is the coding. So evaluate, and we will get the graph. So this is the graph for this closed loop system. And next, we proceed with the theoretical calculation from the equation from the previous calculation. We use that equation to derive into the theoretical calculation, and we will get the PI and PID. So next is the graph for P, PI and PID controller. So this is the sum of all of the graph in one graph. That's type response for one graph. So the graph for P is this, the step response, which is the step response for P is this. This is the coding for step response for P. This is the graph. Next, we will proceed with the PI, this one, and the graph will be like this. And then the last one is PID. This is the PID. As you can see, there is different in the wave of the error caused by the graph. As you can see, the graph show different type of wave, P, PI and PID. So for the first graph, the it's stable, quite smooth, fast, but the best is the PI. and the last one should be the PID because it is too slow for the response. And the last one is the procedure of the rise time, overshoot, and settle time. So as you can see, the rise time for the PI is the fastest, and the overshoot of the PIT is the highest, and the setting time for the P is the is average compared to the others. So for the discussion, the PID control is widely used to control the response. So we use the PID to control the input and increase the control signal to eliminate steady state error. So for the conclusion, the results show the PID is a robust control technique that can provide fast response and eliminate steady state error and reduce oscillation. So the value of Ki, and Kd is determinable as analyze the system behavior in both imagery and real parts. So that's all from me. Thank you.